All right, guys, today we're going to be diving into a new lesson and we're going to be identifying parts of a quadratic expression, and we're going to be looking at standard form. So before we left for the break, we dabbled in standard form a bit where we had the expression ax squared plus bx plus c. And we're going to talk about each part of this expression and identifying what it all means. All right, so a quadratic function that is written in standard form has a maximum degree, new vocabulary word, a maximum degree of 2. A degree is nothing but an exponent. They mean the same thing. So that little number that's in the upper right-hand corner, right there, like that 2, is called an exponent. But when we're talking about a quadratic, we refer to it as a degree. So they're saying a quadratic function that is written in standard form has a maximum. That means that the degree cannot go over 2. So if it has an exponent of 3 or an exponent of 4 or an exponent of 5 or even an exponent of 1, it will not give me this U shape that represents a quadratic. So it has to have a degree of 2 in order to give me this parabola. Anything other would not represent a quadratic. All right, so then it says that terms are written from the largest to the smallest degree. If you notice, inside of the standard form, I colored the ax squared a different color from the bx and a different color from the c. I did that all so I can be able to identify the different terms that they have. So it says that terms are written from the largest to the smallest degree. So let's talk about these terms. Ax squared, this green one, it has a degree, aka an exponent of 2, which makes me name this term a quadratic term. So it's simply called a quadratic term, all because it has that degree of 2. But then when I look at the bx, I see that right here, it doesn't have an exponent, but it has a variable of x. So remember, if I don't have an exponent next to a variable, what's the imaginary number that's up there? Exactly, 1. And because it has an exponent of 1, this is my linear term. It should remind you of good old y equals mx plus b, because when we looked at that, it did not, that slope intercept form, it did not give me an exponent on the variable. And then we get to the c, and the c does not have a letter on it, so it doesn't have an x at all. So since it does not have the variable x, I cannot give it an exponent at all. So this is called my constant term because its exponent or degree would be 0. Let's rewrite that. All right, leading coefficient, another new vocabulary word. All right, so a leading coefficient, hopefully when you think of the word coefficient, you know that we're talking about the number in front of the variable. All right, so I have ax squared plus bx plus c. A is a number, some number. B is also some number. And C is some number. Now, a leading coefficient means that it has to be a number in front of a variable. And the leading coefficient of a quadratic expression is the coefficient of the very first term when it is written in standard form. So leading coefficient means I got to be first. I don't know. I'm Beyonce, and Beyonce is always in the front. So the leading coefficient is going to be in front when it is in standard form. So the leading coefficient of this quadratic expression, since it is in standard form, would be whatever this a value is, because the a is a number. All right. And in order to write a quadratic function, all of my like terms must be combined. And so if we look at this expression right here, they're all different colors, which means I can't add the green with the blue, the green with the purple with the green, and the purple with the blue. I can't add them all together because it is in its simplest form because there are no like terms. All right, so we're going to take that vocabulary and we are going to just have a little vocabulary lesson. So the directions say, hey, I want you to write each polynomial. A polynomial is another word for a quadratic expression in standard form. All right, so that's the first thing we're going to do. We're going to look at each one of these down here and make sure that it is written in this ax squared plus bx plus c. After that, we're going to then identify how many terms I have, my degree, aka what's the biggest exponent of all the terms, and my leading coefficient. Who is Beyonce? Who was in the front when I write it in standard form? So let's start. We have 5x plus 9 minus 2x squared. Is 5x my quadratic term, my linear term, or my constant? And you might have to flip to the front of your foldable, to the upper part of your foldable to be able to see this. And so since my 5x does not have a exponent that I see, that represents my linear term. And then I look at plus 9. Well, it doesn't have a variable at all, so that's going to represent my constant term. And then I have my negative 2x squared. Well, there goes my quadratic term because remember, the square is going to give me that U shape. So I just need to rearrange it so that it looks like this. So would the blue one come first, the purple one come first, or the green one come first if I want it to be in standard form? Hopefully you said the green one. So I'm going to rewrite this. I'm just going to rearrange them so that the green one is in the front. And then I want my linear term to come next, aka my bx, which will be 5x. But I can't just put a 5x because is this a positive or a negative? Well, I don't see anything in front of it, so therefore it's a positive 5x. And then my plus 9. And I have written it in standard form. So I asked, hey, how many terms do I have? Well, how many different colors do you see? I see 1, 2, 3. So therefore, I have 3 terms. Well, what is my degree? AKA, what is the biggest exponent? I have an exponent of 2. I have an exponent of 1. And then I have an exponent of 0. So the biggest exponent that I see is the 2. Therefore, this quadratic expression has a degree of 2. And what is my leading coefficient? Since it's in standard form, my Beyonce is in the front. So my leading coefficient will be negative 2. All right, let's look at the next one. All right, we have 10a. So I'm going to color this a color. It looks like that's my quadratic. It looks like that's my linear term because it doesn't have an x, but it has an a. Either way, there is no exponent on the variable that I can see. Therefore, this is my linear term. Then I have a negative 7 that does not have a letter at all, which is going to represent my constant term. And then I got a negative 8a to the power of 5. So is this going to give me a U-shaped parabola? Hopefully you say no, because that's a 5, not a 2. But then there goes that negative 12a squared. So that's my quadratic term. So now I'm going to rearrange these according to the degree. Uh-oh, my bad. Well, how many terms do we have? There are 4 different colors. I have a blue, I have a purple, I have an orange, and I have a green, which means I cannot add any of those together. So the number of terms that we have is 4. Well, oh man, we should have written them. Go back to this. All right. So I'm going to rearrange these according to my exponent, aka which one of these colors has the biggest exponent on the term. Is it the blue, the purple, the orange, or the green? So yes, it's the orange one because it has an exponent of 5. It's just not going to give me that quadratic shape and that U that I want. Then what will come next? Right, the negative 12a squared. Well, what will come next according to the exponents? Right, the plus 10a. And it's a plus 10a because there is no minus sign in front of it. And then lastly, minus 7. So how many terms do I have? Well, I got an orange, a green, a blue, and a purple. Therefore, I have 4 terms. What is my degree, aka what's the biggest exponent from all the colors? Right, 5. And who is my Beyonce? Who is my leading coefficient? Who was in the front? Negative 8. All right, so let's get a little bit more complicated. We got 6x squared, which is going to represent my quadratic term. Okay. And then I have a plus 5, which is going to represent my constant term. Then I have a positive 6x. Okay, there goes my linear term. And then I got a minus 4. Well, that's my constant term, so I'm going to color it my constant term color. And then I have a positive 2x, which is my linear term. And then I have positive x squared, which is my quadratic term. Now, I cannot, under no circumstances, answer these questions down here, talking about my degree, my leading coefficient, how many terms I have, until I have combined all of my like terms. AKA, I need to add my quadratic term with my quadratic term, green with green, my linear term with my linear term, blue with blue, and my constant with my constant, purple with purple. So I'm going to rearrange these so they'll be side by side. So I get 6x squared plus x squared. And then I'm going to write my linear terms. Plus 6x plus 2x. And then I'm going to write my constants. Plus 5 minus 4. Now this is not simplified until I combine all of this now. So 6x squared plus x squared. What's the coefficient in front of the x squared if I don't see one? Correct. It's a 1. So when I add 6 plus 1, we get 7x squared. Well, let's look at our linear terms. I have positive 6 plus 2. So when I add 6 plus 2, I get plus 8x. And then I have my constants. Which is plus 5 minus 4. And I put it in my calculator. I hope you wouldn't have to do that now. And you would get plus 1. So I have now written it in standard form. And I know, since I got 1 green, 1 blue, and 1 purple, that I only have 3 terms. Well, what about my degree? What's the biggest exponent I see? I have an exponent of 2, and then I have an exponent of 1, and then I have an exponent of 0. So my degree of this would be which one is the biggest exponent, and that's the 2. And who is my Beyonce? Who is my leading coefficient? Who is in the front? 7. All right, and lastly, let's do one more. All right, we have a constant term. No, I'm sorry, that's a linear term. Okay, x, and then we have a constant term, and then I have another linear term, and then I have not a quadratic term because it has an exponent of 4. So I want to write these in order according to my degree, aka my exponent. Which one would come first? Will the blue one come first, the purple one, or the orange one? Hopefully you said the orange one because it has an exponent of 4. And then I have this x minus this x. And then I have my purple -1. So I only have 2 like terms here. So I'm going to rewrite this over here because it's just in the way. All right, so let's just rewrite that. All right, so the only ones that I need to combine are these 2 right here because those are the only 2 blue ones that I have. So that means that my x to the power of 4 will stay the same. But I have 1x because it has a coefficient of 1. And another coefficient of 1. And what's 1 minus 1? 0. They cancel out. -1. So I didn't actually have 4 terms or even 3 terms. How many terms do we have? I got 1 orange and 1 purple. Therefore, I only have 2 terms. Well, what is my degree? What is the biggest exponent that I see? And you're right, it's a 4. And what is my leading coefficient? Who is my Beyonce? Who was in the front of this? Oh, Miss Carter, I don't see a number right there. What's the imaginary number that I see? You're absolutely right. It's a 1. So my leading coefficient is 1. All right, guys, I hope you got some good notes off of this because we're going to need this for the next lesson.